Hello everyone, and welcome to the first episode of my tutorial series on how to make a simple Aluminium 2 AI for your fighting game, or mod. This is a totally original idea that I totally didn't get from anyone else. But yeah, let's get started. So the first step is where you want to have your AI located. So you're going to want to get a simple file directory. Then you're going to want to make a blueprint class and select character. We call that ch_base_npc. After you open it, this is what you should see, which is going to be the blank slate for our entire AI system. So you're going to want to select a mesh, click on this box here, and search up the neighbor body and set it to his body. Then you want to do -90 on the z-axis, and for rotation do, I think it was -90 on the z-axis too. Then you're gonna want to click add component and skeletal mesh. I call that head. Then you select the neighbor's head and assign it to that, and then just undo the previous settings that we did for the body. One thing I also want to mention is that this is Jack's template that has all the meshes and stuff for the game. That'll be linked in the description. Anyway, back to the AI. So to give the AI animations, you're going to want to make a new folder, call that animations, open it, and make a new animation blank space. Set that to main skeleton. We call it bs_neighbor. Then open it. Then you have this panel here that has all the animations for all the characters. But the first thing you'll want to do is set the horizontal axis to be named speed, the maximum horizontal axis to 750, and the minimum should make sure that that's 0. And then you're going to want to get idle, calm. Make sure it's a neighbor's idle calm animation, and drag it out here. Then you're going to get walk, calm. Make sure it's a neighbor's one. Drag it out. Select it. Make sure that it doesn't snap to the ground, and set its speed to be 200. And then now this is the basic animation blank space. You also want to get calm on. Repeat the same process of snap to get and set that to like 500. And then the last animation is sprint. The neighbor sprinting animation, and just put that at the end. One thing I should mention is that all the animations need to have their age scale set to 1.25. to more closely match what what they should look like in the game. The second thing you'll want to do for animation is to make an animation blueprint. And make sure it's assigned to main skeleton. Again. Call it AVP_base_NPC. And this is the part, the blueprint that controls what animations play and all that kind of stuff. So we're going to cast to ch_base NPC, and just drag that out to drag it pawn owner. And then you'll want to make a new variable. Instead, you'll name that speed. Set that to be float. Then drag it out here to be set. Then you get velocity. Then you do a vector length xy, and then you drag that out to speed. So basically, this float will be set based on the speed the neighbor is going. This is just our basic setup. The first thing I'm gonna do is just make a new state machine. Call that base Then you want to open it and drag out and add state. You call that movement. Then you open it. Then you get yes_neighbor. And then you set that to the speed float that you just made, and connect that up to the speed variable on the blank space. You hit compile, and the neighbor will have his auto animation. You're gonna want to go back into your base NPC, select his body, then set that to ABP_base NPC. Now you'll notice that his head still doesn't have any animations. So you're gonna want to open up the construction scripts and drag out of that. Then do set master component head. Then on this new master button component, you set that to be mesh. And what it should do is make his head use all the animation blueprint that's on the body. So now his head will always be connected to his body in editor and in game. Here's where we start getting to the real AI parts. So what you're gonna want to do is add a component and do perception. And you're gonna want to go to Sensors config, click a plus sign, and then on this drop down set it to the site config. Then click this drop down here and this one, and then you'll see all the settings. So the first thing you'll want to do is set the peripheral version to be 85, since that just works a little better in gameplay. And then what you're going to want to make sure you take is make sure that it can detect neutrals and friendlies. Okay, now what you're going to want to do is go into the event graph and delete these two nodes, because you won't be needing them, and just hide that comment. You're going to want to make a new custom event. We call that sensing update. Drag off the timer by event. And set that to 0.1. Make sure you took looping and then event. Then on event begin play, you're gonna want to call that custom event sensing update. Because what this does is it constantly calls this custom event once it's been activated, which I'll use to make the base of the entire sensing system. You're going to want to click on your perception component, and then on target perception updated. Now I put this in a separate event graph for the sake of organization and call that sensing. Then put this in here. So I've just got it set up here. You're gonna want to get on perception updated, and then you're gonna want to make sure that it's calling the right class, because in the future we're gonna add like hearing senses and stuff to this. So get class for stimulus, then you want to drag out and do an equal class, and make sure that that's equal to AI sense _ site. And if that's true, then you cast to Quinton. Just drag its connected object up to actor here. And then we're gonna have a set a variable that you make. You click on the plus and do the boolean here. And then you're gonna want to drag off stimulus and break AI stimulus. And then you connect successfully sensed and connect it to this boolean. And that should be it for making it actually sense the player. So now we're gonna do the rest of the code. Back here where we made this constant event, you're gonna wanna drag out and make a branch. And you're gonna make the condition is player inside the boolean that you made. And if that's true, then it's gonna call the attacking code and everything. But before we do that, we have to actually make the brain of the AI. So what you're going to want to do is make a new folder, call that AI behavior. We're gonna make another folder, call that behavior trees. Just behavior tree with our space. And another one, a blackboard, and call that db underscore opponent. What you're gonna want to do then in the behavior trees folder is make a behavior tree, call that bt underscore base. In the AI behavior folder, you're gonna want to make another folder, call those enums. Then you're gonna wanna open this, go to blueprints, and click enumeration. Call that e underscore state. Then you open that, and you click new. 1, 2, 3, 4, 5. And then you want to make idle hunt. I'm just gonna capitalize it. Chase or attack. Capturing. And for debugging purposes, none. And those are the main states that you're gonna use, if I'm not mistaken. Next, you're gonna want to go back to behavior trees and make a new folder for sub trees. I'll explain why. Because each behavior is gonna use its own behavior trees. So BTS, no, yes, BTS, behavior tree sub, or sub behavior tree. It's up to you what you name it. Attack. And first, what you're gonna want to do before actually progressing is go to BB behavior or opponent, and add an enum and call that state. Then click on this drop down and set that to e underscore state. Then compile or save. And then it should appear in the behavior tree after you reopen it. Also, it should be saved. Set self actor in the blackboard to be the AI that you just made. So ch underscore base NPC. And then in the base NPC, on a you do event possessed. Drag off that, and then you want to untick context sensitive and do run behavior tree. Set this to AI controller, and just make sure you set the controller actor to self. Then you want to set BT asset to BT underscore base. Not just for now. All we're gonna put on true on this constant event is a sequence. And then you're gonna want to make a new function. We call that set state. In variables, you make a new variable and set that to state. In Boolean, you go to e underscore state and just set that to this. And compile. Then you're gonna want to manually do this, drag out, set, and then you want to drag onto the function node so that it makes this part of the node. Now here comes the tedious part, which is getting the AI controller. Self. And then you get the blackboard. Get blackboard. Then set value as enum. connect it up to there. Drag this into here and then make literal name. Now you want to gotta go into your Blackboard, get state, and name this to state. So it sets a state variable in the AI, and then it goes and gets the enum in the Blackboard, and sets that to the state variable. So then on the sequence, you set state. You get your state function and set that to attack. Now in your BT base, you drag off of there, selector. Then just off to the side, you do a sequence. And then you're gonna wanna right click on it and add a decorator, a Blackboard one. And then set the Blackboard key to state, and then make sure that do is equal to attack. So what this does is it makes the selector choose whether or not the state is set to attack, and then you do run behavior, and then you set that to SVT_attack. In SVT attack, you're gonna wanna drag off and do another selector. Now you wanna go into your Blackboard and make another variable and call that is player in sight. And now you go back into the base living graph, and then you're gonna want to put another construction script, and then call that set player in sight. Then you connect that to this variable and do the same step. Get these, but instead of getting the value as the enum, you set value as boolean. You see, ename, make literal name. The BB opponent is player in sight, and then set the name to be this, and then just connect this up here. So now you go back into SVT attack, and off the selector you do a sequence here. Then you do. For now, I'm only gonna make him chase you, and in the later part of the tutorial, I'm gonna do his sparring animation and stuff. So you're gonna want to click here and make a new task. This task should be here with your sub tree. I'm just gonna move it back to the behavior trees folder and call that BTT_attack. Now, what you do here is you event receive execute AI. So when it gets called, it calls this node. Then cast to ch_base NPC. Set object to the control pawn. Then do AI move to. Then set pawn to the base NPC. And for target actor, you get player character. No. Get player character. Then you just do finish execute. Now this is how you structure all of your behavior tree tasks. It starts with event receive execute, and then you got the code, and then when it's done, you do finish execute, and then you have to make sure that success is set to true. So now you're gonna want to go into the the attack behavior and call the task that you just made. So you do BTT attack. Now what you do is you go into your map, get the NPC, place it in the level, and then get a nav mesh from the place actors tab. Nav mesh bounds volume, and just make sure that that covers the entire level. Or the entire area that you want the AI to roam on. Now if we go in game, he's gonna start chasing you. Now you may have noticed that his rotation is a little messed up. And there's a really simple fix for that. You go into the NPC, select the self component, and search up rotation. And make sure you set this to be false. Use control rotation pawn, or yaw. Then go to the character moving component. It said orient rotation to movement, and then compile. And then if you go in game, you're just gonna properly rotate towards you. Now in your base NPC, you're gonna go out and go back to event graph, and then do a delay. So this delay, it's a triggerable delay, so that it can be called multiple times. But what's gonna happen is this is gonna go off the sequence and constantly set this. But this is only gonna get reset if the player is in the AI side. So what's gonna happen is if you're not in the side, that's gonna go false. This delay is gonna count down to 0, and then it's gonna call his next event, which I'm actually gonna use something else for this. And instead of making it set this variable, I'm gonna make it set the player inside thing directly. So now you're gonna wanna get your function and make it set this to false. Now I should also notice that mention that you should make another node in the sequence and that sets this to true. And then in your sub attack, so sub J attack, on the sequence you add a blackboard and set this to if the player is inside, and if that is set, it'll start attacking you. Then copy this sequence, paste it, and then you're gonna wanna have this is not set. So now if he doesn't see you for like 30 seconds, it's gonna set this to false, which is gonna trigger our next event, which I'm gonna cover in a future episode of this series, as I'm only focusing on attack mode right now. So now it's time for us to polish this up. So what you're gonna want to do is add another sequence, set it to forced access, and add a cooldown. Set that to like 5, which it is by default. Then I'm gonna make a new task. Now this task is gonna make the AI rotate towards us. So behavior trees. I'm just gonna you just gotta do the same steps here, and you're gonna want to get move component 2 and get the AI's root component. For location, you're gonna want to just get relative. No, you're gonna want to get the relative location of his root. Get relative location. And then you're gonna want to move this back and cast to th_Quinton. Just connect this up to get player character. and then you're gonna want to get actor location, and do the same for the AI. Now what you're gonna want to do is find look at rotation, and you're gonna want the start to be the AI's location, and the target should be the player's location. Now you're gonna want to split this, leave this down, and split this too, and only drag in the Z-axis. As for the rest of these, you're gonna want to drag off this relative rotation. Do the same here, split it, and connect the XL and Y pitch onto these. I do forest short rotation path and set this to 0.5, and then on completed, finish, execute. So now we're gonna want to go to attack, and over here drag in the task we just made. I haven't named it yet, so I'm gonna name that to BTT_lerp to player rotation. So now what it should look like is that. Now it's a little slow, so I'm just gonna set this to back to 0.2, which is its default value. And there. Now he smoothly turns to the player. Now we're not done yet. So what you're gonna want to do now is open the AI and add a variable. I call that spotting animation. You're gonna make a new category for this and call it montages. And you're gonna want the variable type to be anim montage. You're gonna wait. You should click the eye icon so that it's a public variable, meaning you can change it just from selecting the AI. Now you want the base variable to be the base value animation to be signature as possible nearby. Once again, just set the animation speed to 2.5 because all the animations are slowed down for reasons I don't know, to me at least. Then you're gonna right-click on this montage and make a montage, name that AM_spot player. So then you're gonna spot player. You're gonna open the AI, select the montage, and set this to AM_spot player. Now the montage isn't actually gonna play in game yet because there's one more step you're gonna want to do. Oh, also because I haven't coded it yet. You're gonna want to go movement. Oh no, not movement. The anim graph. And drag out of the state machine and do default slot. Now, I noticed that I stopped on the naming. You're gonna want to make a new task again. I'm just gonna make this a base so that it's automatically in the application. Do BTT_play spot thing animation. Now you just do the same thing again. You want to drag off and get mesh. Make sure that it's the component that you're actually getting. Do play montage. And now you also want to drag off from spotting animation and get it. And connect that up to montage to play. Then on completed, you do finish execute. And should you save, you do interrupted and then success true. Now go back into the attack, and next to this, the lerping, you do play spotting animation. So now if he spots you, he's gonna lerp towards you, play the animation, and then start attacking you. Now you may have noticed that it looked a little funny there, which is probably because in the montage, okay, it's because I changed the speed of the animation after making the montage, so you just want to go, you're gonna want to rephrase this by just getting C trace crossing. Just gonna want to drag this out again. Still slow for some reason. Oh no, that's just its speed. Okay, now it's normal. So, as you can see, now he goes and starts chasing you. After playing the animation and stuff. Now the only thing that's left to do is the chase music. And of course you're going to want to add component and get an audio source and name that chase music. And I'm just going to set that to hideout chase. Make a sound cue. And just to make this sound better, I'm going to do what they did in full game and put the I don't know what that's doing. And just make these two mix with a mixer. Like that. Now you're going to want to set the chase music to be hideout attack, the sound key you just made. In functions, you do the music updater. Please. Now you're gonna do is switch on state, switch on eState, and drag your state variable into there, and then get the chase music and do fade out. And I could do once node. Make the fade out duration to like 0.6 or like 1.2. It's really up to personal preference. And make it hunt mode and none. Make fade out. Now chase music and do for the attacking and chasing. No, attacking and catching. You do activate for the attack mode and deactivate for the catching. So, and make these two resets the do once node and give them each their own do once. This code might get a bit messy, but that's just part of game development. And give these two each their own do once node. That gets reset by these. Like that. And this should work. So in the main guy, what you're going to want to do is copy this and do constant pick. Set this to like 0.01, a sequence, and in that sequence you put your music updating function, and on begin play you just call the pick. But now if he attacks you, oh, okay, yeah, one thing you gotta do is select chase music and make sure auto activate is set to be false. So now if he's gonna see me, he's gonna play the chess music and start attacking me. So that concludes everything that I'm gonna do in this episode of the tutorial. I'm gonna get the idle mode tutorial out next as soon as possible, and then followed by hunt mode and then all the other extra features. But I do want to mention that this doesn't work on only Neighbor 2 AI. You can do this for Neighbor 1 fan games, Neighbor 3 AIs, etc. If you have any suggestions on something you want me to cover specifically, you can just let me know, and I can either record it and post it to YouTube, and if it's something small, you can DM me on Discord and I'll record it for you exclusively. So yeah, thanks for watching, and I'll see you in the next episode where I'll be explaining the idle mode and fixing anything I missed in this episode. Bye.